following podcast is recorded and produced by the Podcast Precinct in affiliation with the network at bicbp-radio.com. The Podcast Precinct. Consistency, creativity, culture.
Hello and welcome to the Sci-Fi Update. I'm your host Tony Harper, and with me in studio today I have my friend
Ryan Chase.
Sorry, Ryan. We've been hashing some stuff out beforehand, and I got my mind wrapped around a couple of things here. So to begin with, I usually would start off with the news, and today the news, there were a couple of things out there. There weren't a lot. Start off with Strange World is a new Disney feature coming out. It is supposed to come out November 23rd, and it's an animated, same people that made Big Hero 6 and that kind of stuff in it. They didn't really explain what it was all that much. I did know that it's based on a paperback under the same name, and it's basically kind of a futuristic fantasy creature type of thing, and it was just seemed interesting. I Am Groot will be a new series that starts up from, who was covering this? There's a new series coming out of that, and I wish I knew which podcast thing it was on, but I forgot to write that one down. And there was one other brief news article that I was going to cover today. Let me figure out. This was a Vietnamese show coming up. Micah, Girl from Another Galaxy. It's a Vietnamese science fiction movie, and it's slated to already have hit theaters. It was supposed to hit theaters June 3rd. This will come out June 13th about. So if you have a chance to see it, don't forget to go back to see that. And today's podcast will be about the science behind, which is why Brian here is one of my engineering buddies, the science behind how ships move through space, and all of our science fiction stories. Ryan's got a mechanical engineering background, so he's going to help us describe how we could kind of get about moving through space based off of some various different ways that we're going to do it. Which one do you want to cover first, hyperspace or warp drives?
I think hyperspace leads into warp drives.
Hyperspace leads into warp drives. All right, so we'll start off with hyperspace. So who uses hyperspace? We got Star Wars uses hyperspace.
Does Stargate use hyperspace?
Stargate would use hyperspace, I believe, maybe. I mean,
it's kind of a hyperspace concept.
Wormhole technology.
Yeah.
I mean, that might be thing. But how do the ships move? Do you remember from Stargate?
The ships.
Yeah.
I would imagine that the ships are probably using some type of an ion thruster or something like that. Some type of thruster.
Well, they are, but they also have faster and light travel. I mean, that's how the aliens got to the pyramids thing. It's more of a warp drive.
That's how they got to the first. Actually, I can't remember what their exact technology was in that particular one.
Did you watch all of Stargate all the way through seasons?
I watched a bit of Stargate. I did not watch the entire thing. 10. I wish I did. I did like that series.
It was a great series. I actually have all of them on CD. I Napstered them all, and I actually still own them all.
One of my issues is I was out of the country for about 5 years, so I lost a little bit of time on the sci-fi stuff, but and I had some health issues, which I lost a little bit of time, so I have some gaps is the problem.
But did you see it in the Stargate add-on shows? What was it? It was, SG-1. It was the other two that were add-on. Stargate Universe or Stargate... What the frick was it called again? Stargate... 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 Atlantis. Stargate Atlantis.
Did not see that one.
And there was another Stargate show.
I watched the one with the guy with the glasses. And
that's the original. That's SG-1.
That's the SG-1 was the one.
Yeah, that was the original one. I liked SG-1. Stargate Atlantis, and I thought it was Stargate something. I wish I knew. And my phone being down here is just SG-1. What else do we got here? Atlantis and Stargate. Dang it. I'm picking it all up on here. Yeah, it was Stargate Universe.
Okay.
And then they had an animated series called Stargate Infinity that ran for 2 seasons. I didn't see either.
Boy, we got to do some catch up.
Yeah, I got to catch up on that one too. Stargate SG-1 ran from 1997 until 2007. Atlantis, 2004 through 2009. I wasn't a big fan of Atlantis too much.
What about that? Star Trek Discovery, where they're warp jumping using the tardigrade energy.
You're right. That was interesting. I have not finished watching all Stargate or Star Trek Discovery, but yeah, it was the tardigrade was able to read whatever the lines.
There was so the universe has dark energy lines through it. And it's able to map out that filament energy, and the filament energy was able to use that to the special. I forget what the thing was in the cylinder that they put in with the special.
I forgot what it was too.
The structure, and it was able to energize them to be able. It was some type of chemical.
Drive.
It was some sort of the drive, and they're able to put this. Thing in, and it energizes the core,
right.
And they use the tardigrade's mental map of the universe that it's able to plot where they wanted to go, and they kind of tell it where they want to go.
It sounded more like the improbability drive.
Is that
the name of it?
No, it had a different name.
From Hitchhiker's Guide to the Galaxy.
Yeah. I've heard of that.
So that's what it sounded like to me, was they're more like the Hitchhiker's Guide and Probability Drive, which I thought was a unique take on faster than light travel as well. So let's go to hyperspace. How do you think hyperspace would work?
Well, one of the things I've studied, so I really like physics, and I was very into Einstein's theory, and I have a friend I talk to all the time about, he's very interested in quantum theory.
Right.
And he's always talking about Schrodinger's theory and whether it's he's always talking about that. And so one of the things that he brings up is this notion that the universe is connected.
Right.
And so what happens is any particular charged particle is sending out wavelets of energy in the electrostatic spectrum to every other particle in the universe. And every particle is connected to every other particle. And you can, what do you call it when two particles become synced? Not superposition. I've lost the word.
It's how the Ansel works from Ender's Game. The Ansel does.
We've lost the word, but anyway, everybody knows it. And two particles can become harmonized in the universe, and then mimic their behavior and become linked. And what that is it's these underlying waves that are pervading the universe of energy, of electrostatic energy, and electrostatic energy is rooted in the gravitational theory. And the gravitational theory bends space-time. So space-time, energy, and the electrostatic field, as well as most likely all the other fields, interconnect all particles in space-time, of course limited by the speed of light, which kind of is just the wave speed of that link-up.
Right.
So whenever you touch something like a table, that wave of energy comes out from your finger and spreads throughout the table And have you ever seen the table with the salt on it, and they vibrate the table, and it creates the patterns on the table?
Right.
And what that is that's the vibrations pervading the universe, and that's sound energy, or mechanical energy. But there's also this electromagnetic energy, which is also the gravitational energy, and it pervades the universe and allows us to allows everything to be interconnected. So it's like a butterfly flaps its wings in China, and there's a tornado in Texas. And that
quantum entanglement.
Quantum entanglement. Thank you. I needed that. I lost me for a minute. But the entanglement is actually a property of the way the electron works.
Right.
So my theory is that mass is basically two charges superpositioned. So what you get is a positive charge and a negative charge, and they're sitting on top of each other. And this may or may not be true, but this is the way I imagine it. And they're neutral in charge, but that energy, or that electromagnetic energy, neutral, is still there.
Right.
The charges haven't disappeared. So even though that's neutral energy, there's an energy that it has, which is mass now.
Right.
And that mass has the property that it curves space-time. Now we talk about space-time, but it's not the space. It's more the time that's curved, because Einstein's theory, when it's reduced down from the full set of equations, becomes a time subset, and the time subset is acceleration. So you get that meters per second squared as your, and that second squared is a curvature.
Right.
And so a radius squared is basically v over r squared is your acceleration. It's a curvature of radius, like you're going around in a circle, and it's a time curvature. So Einstein's theory basically says that there's a time curvature to energy that is related to the electromagnetic theory, which is energy corpuscles of virtual particles of light that interact with everything and create everything that we see that exists.
So like what you're saying is, like, say you have that black hole, right? And we've got that picture of that black hole, right? That NASA's now been able to take, because like a star kind of was falling in a black hole, and they were able to see kind of sort of the event horizon, not exactly, they can at least see the energy coming off of the stars that was falling into the black hole, and they created a false image. And it's all round and circular because that gravity and everything's really just bending space-time, right?
So
what time?
It is so you're asking me, is it space or is it time? And the answer is it's both, because space and time are connected, and because the speed of light is a certain number, and the space and the time. So whatever you travel through space and time.
Right.
So they're both the same thing. So whether you're curving space or you're curving time is really kind of a moot point. You're always traveling through space and time.
Right.
So if you say, are you curving space or time, you're curving both.
So how does hyperspace work?
So the real question of hyperspace is a theoretical idea. And
right, of like multiple dimensional space.
Multiple dimensional space. So what I think Mikio Kaku wrote a book called Hyperspace, and I did not read it, to be frank. But the idea that I get is a lot of string theory and all of that talk about wrapped dimensions. So let's say we have the X, Y, and Z coordinates.
Right.
And what they say is that there must be another dimension somewhere in there. And what I imagined is that it's a corkscrew going around the other dimensions.
Right.
So you add a dimension just by corkscrewing the other dimensions. And it's kind of like a spin. And spin is this concept that we actually don't completely understand. We're trying quantum computers, and we're getting the idea of how it works. We know a lot about it. We do know a lot about spin, but we don't know everything about spin.
Yeah, we got enough that we can read it and stuff like that, but most quantum computers are actually only doing it simple problems. They just do it really, really quickly, because we can't really figure out what's going on with the spin.
Well, the spin has to be interacted with light.
Right.
And or electromagnetic energy. And we use electric energy to interact with that, and then that disturbs it. And then we have, so you need something not electrical to interact with a quantum computer. And then, so you have to like bridge it into a normal computer right now,
right.
or a fiber optic, or something like that. And that interface right now is we can do certain types of calculations really fast with a quantum computer. But the problem is there's this. We're using. We got to go through our current technology to get to the other technology, which is really the limiting barrier right now, because you have to go through a normal computer,
slower normal computer to get to the information from the faster computer.
So the question is how do you make that quantum computer works? And the other issue is it's not stable.
Yes.
So
so it actually does like the computations multiple times to see what the average is to come up with the answer or something like that.
It does have to do it multiple times, but not as many as you might think. So the problem is that it flips, and quantum is not always 100% probability. It's got a probability to it. So there's not a certain thing like an electron is there or it's not there.
Right.
A quantum state is. People say that quantum is really complicated, but it's here's what I believe is a quantum particle is my theory is it goes through the boxes and it comes out spin up or spin down, and the boxes are supposed to be Schrodinger's cat problem, whether it's up or down. And I believe that these particles, when you interact with them, that's what flips them.
Right.
And so when we're observing them, that's what flips them. It's like let's say the particle is aimed at 45 degrees.
Right.
And you don't know if that's up or down yet. But as soon as you interact with it, it flips up.
Okay.
And then it comes out the other side, it's always up. So our interaction has now told us what we get.
Right.
Is it
truly up though?
And then it's a probability of being up or down. You have to observe it to get it to be on the other side. So there's some mysterious stuff going on there, but the point is that it may not be as mysterious as we're making it out to be. I think a lot of science doesn't want to speculate on what's really going on if they can't prove it. But the truth of the matter is it may be something.
But wasn't that what Einstein did? He speculated on a lot of stuff he couldn't yet prove, and that's how he came out his theory. And that's why it's still theory.
It is still theory. So it is still
theory. But it's
theory.
a very valuable theory.
And the reason it is a theory and it's not certain is because we just don't have an experiment. It's not that it isn't really sound logic.
Right.
It's really sound logic. And a lot of his, one part of his theory is proven. Gravity does exist, and his equations are no different than gravity, so that part's proven.
All right.
But the part that isn't proven is the subset of equations that deal with the electromagnetic theory being gravity. And that particular subset can't be proved. Well, it can be proved. I'm not sure if it's proven. I can't say that for certain. So you have to need a really strong electromagnetic field and then get gravity out of it. So how do we build a really strong magnet and get gravity from it?
And we still haven't determined what actually
that may be
causes
really hard to
gravity
do. I don't know if
yet.
I've done it yet.
And that's what we really kind of need to be able to get some of these faster than light travel things to even started off the bat, right? Is to figure out what actually causes gravity.
Well, so one of the things that I imagined is I actually prefer the Stargate over the warp drive because
wormhole technology.
Yeah, because let's say it's actually the problem with transporting a vessel with a warp drive is it has to produce a gravitational anomaly.
Right.
And the gravitational anomaly is, say, a black hole, and every mass, every kilogram of mass is 10 to the 16th c squared mc squared equals energy, amount of energy, and to create enough to just make a ball fall at 9.8 meters per second squared on Earth.
You need something the size of the Earth.
Well, the Earth, and how much energy is that? That's an unimaginable
number
of energy.
Figure out, and then when you even think about it further, as you go into Jupiter's 300 Earths, and then you get into the Sun, which is how many Jupiters or how many Earths?
Not a lot of acceleration for the amount of energy you've got there. It's a lot of spatial distortion. But the problem is you need a tremendous amount of energy to do warp drive. I think it would actually be energy cheaper to beam the information electromagnetically to the destination and rebuild the molecular structure from scratch, if that were possible. It's actually a more plausible theory because it would probably take less energy to build the matter than it would to generate the warp field.
Okay. But they figured out by oscillating the warp field, you can do it with way less energy.
That's an interesting
and magnifying the thing. Because there was that one article, because from what I remember, there was one article done by, I forgot where the student was from, but he basically took the math, they got the math that it was the same amount of energy that a city would take in order to create a warp bubble. And the original math said you would need something the size of our star to do it. So he figured out utilizing the math and basically oscillating the energy and creating just like that fluctuation. It's like a real quick bubble that comes into existence, pops out of existence real quick.
So that brings up one of the things that Tesla created was called an earthquake machine.
Yes.
And Tesla, one of the issues with energy is any type of rotating object, if it's imbalanced, it creates a vibration. And a vibration is tremendously damaging to mechanical equipment.
It is.
So let's say you oscillate a warp field, you would be vibrating at high energy the entire ship, and it would probably shake it apart. So Tesla's earthquake machine was a device that could fit on a table.
It was a shoebox-sized device that he used to practically bring down a building or a bridge.
He was trying to generate energy from it.
Right.
And he did generate a tremendous amount of energy from it, and it was a small piston that would slap back and forth based on steam power by a series of fixed valves that oscillated back and forth with the machine in the piston, and that would drive an electromagnetic actuator, and he would generate energy and it would flop back and forth. The problem is, the damn thing shook the entire block and took out the entire it basically took out the block. It almost took down the building.
Yeah.
And he had to hit it with a sledgehammer to shut it off before the building collapsed around him. So the problem with oscillating a warp field is that it'll probably shake the ship apart.
Interesting. All right. So how do we get the wormhole or the hyperdrive? Because you were talking about spin and what would we need to be able to even produce?
Now, if you could create an unsteady wormhole, it would vibrate. But if you could do it, the problem with this vibration theory is that it does shake things. So how do you create a wormhole? The only way we know that may even be plausible is that when energy goes into a black hole, it comes back out through the event horizon.
Right.
So is that a wormhole type of scenario? So is that tiny wormholes in the surface of the black hole that the energy is now radiating, the Hawking radiation is coming back through.
Yeah.
So
Hawking radiation I thought was basically more like a cooling of the of the black hole itself, because the black hole is generating a lot of heat and the heat needs to kind of radiate out.
So could that be little tiny wormhole type scenarios that are occurring in the surface, because the energy technically can't?
Yeah, but that's not controllable for us.
I mean, in linear theory, it doesn't come back out, but in thermodynamic theory, it comes back out. It's kind of like it's kind of like Brownian motion. Every once in a while, even though it's solid, it's not solid. The atoms in the table are always moving.
Right.
So the surface of the black hole is always moving. So you always get something ejected every once in a while. And it's just because of the undulation. Nothing is ever solid. So maybe we have to tap into that nothing is ever solid theory to poke a hole through the universe and find the undulation and create a wavelet that we find a hole and we can pass what we need to through it.
Yeah, but then we're talking, again, very small amounts of data if we're just passing.
Well, if we can pass even a small amount through it at a really high rate of speed, then we could maybe send a stream and kind of get a teleporter Stargate type of scenario. But so the question is, can we? But how do you move material, and how do you get the destination, and how do you do the coordinates? That's all sci-fi, and I'm not sure I have the answers for that particular question.
Okay, I like where you're going with that, and it was just kind of like our discussion the other day we had online about how galaxies were moving faster than they should be around another galaxy type of thing, or why they kind of go to an edge.
Yeah, curvature. There's a
instead of like always going smack on, they tend to hit in an edge, and basically even stars and
why are
galaxies
flat? Why are galaxies
right.
spiral shaped? And so one of the things in nature is that we can't even predict why tornadoes occur where they occur. There's a chaos theory that allows, I call it the finger of God, because that's what a tornado is. And it allows for things to spontaneously occur in nature that can't be predicted experimentally. Well, you can predict a smoke ring. You can't predict where it's going to dissipate or what type of air current is going to cross paths with it. There's too much going on in the universe.
Too much information.
There's way too much information, and it causes these undulations in the...
And the closer you get to figuring out that information, the more likely you are to change that information to something else.
Yeah, it's kind of like a pot of boiling water. You can't predict where that bubble's going to be. And it's the finger of God that allows the magic to happen, at that bubble to occur where it does. And it's kind of a miracle of sorts how the universe manifests itself.
So we really need that quantum computer that really does deal with those fuzzy numbers.
If we could compute, well, it actually can't be computed. There's actually maybe let's say one day AI and quantum computers come out and they figure out something that I don't yet understand, and they figure out how to work with the interconnectedness of the universe and tie into that tardigrade network of reality, and tie into that hive mind of reality, and figure out where that undulation is going to occur. Then maybe we can tie into that super powerful nature of reality that allows the magic to happen.
All right, so let's slow down. Let's go a little bit more hard science versus as much science fiction.
Hyperspace is very hard. It's very hard thing,
but something like an ion drive. That's easily understandable and all that kind of stuff, but realistically, how fast first off, how does an ion drive work?
So they pump a gas, an ion, into the ion chamber, and they hit it with a cathode ray, and the cathode ray excites the ion into a positive and negative charge, and that ion is then kind of escapes into the plates, which are charged, and you can only get so much charge, which is the fundamental limitation before it breakdown voltage, and that charge is then accelerated at extremely high energy and speed out the back. And even though it's a tiny amount of gas, which is the limiting fuel, and this limiting breakdown voltage of the capacitor plate that is porous, and the ions kind of jump in there and then shoot really, really fast like a gun out the back, and that creates momentum. And then, so even though it's a tiny amount of gas, it's going super fast. I forget what the speed is. It's on the order of
the speed of light, though.
It's very fast. It's on the order of on the order of like 100 meters a second or so, or 100 kilometers a second, so or something like that. I can't.
Yeah,
remember.
I thought it was like 0.3 C or something like that.
Well, let's say it's very fast because we know it's that, and it comes out very fast, and it's just by order of that speed that there's any energy momentum at all in the ion drive, and the current problem with ion drives is I think the ones that are built are usually around the order of 1 horsepower.
Right.
So
it takes a long time to get doing anything with it. It's a build up of speed. You can get it going pretty fast eventually, but it's that slow build up of speed. So in order to get a functional warp drive for, like, say, a starship, how much horsepower do you think you would need?
Horsepower. Oh, you're moving a small city up to the speed of light. That's
well, let's get it reasonable. Let's go with 0.3 C. That's my honest goal, because we get it down to there, it's close enough we can actually get to one.
It's all about acceleration.
Other solar system than ours, and back in a lifetime.
Well, I'd have to do the calculation. It's basically the MV squared. I mean, let's just do it MV squared, right? And it's tremendous. I mean, I don't even know. I do the calc. It would just blow everybody's minds.
It would be a big, big number. All right. So what other engines were out there that we were talking about?
Well, I like the solar sail.
Solar sail. All right, yeah, that was another one I mentioned to you.
I don't think you mentioned it, but
that's fairly easy.
So I like the idea. I'm a pessimist, and I used to be an optimist, and I used to watch all of the green energy, and I used to watch all of the sci-fi, and I used to be enamored, and I went into engineering thinking it was going to...
You were going to change the world.
I was going to change the world. It was going to save everything and make everything wonderful. And I love that. It's a great thing. Everybody should have hope. And we all need that. But then I kind of had an awakening, and I got into the numbers and the science, and I started realizing the limitations. And a good engineer needs to know limitations.
They do.
To be able to actually, because you need to know what can stop you before you know how you can move forward.
Right.
So we were talking about which drive?
Solar sail.
Solar sail. So the solar sail is a great idea because it's got a limitation though. The solar sail would be great because a lot of forms of interstellar travel require you to have fuel, propellants. Stored battery energy, solar panels, all this stuff that you need to generate the energy, and you run out of energy. But if you can solar sail off the sun, then you're using the energy around you, which is like using a solar panel. But a solar sail actually works on the radiant energy of the sun, and it catches the photonic energy as a boost. Like, have you ever seen one of those little light things in a glass jar with the white and the black painted on each side, and you put it in the sun and it spins. Right. And it spins because the light heats up one side. But this isn't heat. The solar sail actually works off the principle of the light energy's momentum.
Basically catching the ions and having
those photons and ions, to be fair.
Yeah.
And that propels the ship away from the sun and allows you to get the speed you need. And it's the most reasonable idea, but the problem is that space is full of junk.
It is.
And it's full of dust and debris. And a solar sail is huge and thin. And that junk is going to hit that solar sail, and it's going to put holes in it. And the holes, well, it may not be a big deal. Over time you're going to have a lot of holes in the thing that you need to get wherever you're going. It's one of the more reasonable ideas, but it takes a long time to speed up. And the limits of going into space. How long did they put an astronaut into space for? A year?
About a year or so.
And
A little over a year, but it's been about a year.
The trouble is the human psyche just can't take the stress of being at work doing prison time on a spaceship without human contact for years on end, and it would be most people, unless there's something wrong with you, that you would be able to do this. You'd have to have something wrong with you to be able to do a multi-year interstellar travel, to be able to handle it. And I think you need an extra special person to do that.
Interesting. All right. So solar sales was covered. I mean, when you're saying all that space junk, like I know, like the James Webb was already hit with a significant debris in one of the mirrors.
Yeah, it happens. It happens.
And it threw one of the mirrors already out of alignment from just a micro mirror.
Yeah, that's all it takes.
I think they were able to get it fairly realigned, but they were already experiencing some micrometeorite damage because of that kind of stuff.
The joy of our technological age, fueled by all of this fuel that we have, has allowed us to imagine that technology is going to bring us to the stars. Right. And we have learned a lot. It has done so much for us, but there's limits and realities that are out there that we've done a great job dealing with, but it's a problem.
It will be a problem. Will continue to be a problem, and we'll bring you back on for our dystopian futures.
I think I'll be excellent for that.
You'll be perfect for that one. How we're going to get there?
I gotta watch a few movies before I come,
and what we can do about it. So I'll definitely bring you on that one. Let's see. Covered solar sails, ion drives, hyperspace. Did we really cover wormholes? I mean, we kind of did.
A wormhole. There's not much to say. We haven't seen one, and we don't imagine. We don't even know if they're real.
They're just theorized right now at this point.
Yeah, all that material going on that black hole got to go somewhere. Maybe is the theory, but as far as we know, it stays there, and we think it stays in that black hole
until it gets radiated off by Hawking radiation.
And we don't know what it is when it's in there. Maybe it's so intensely hot, it's like, I guess, plasma, with maybe even photonic energy inside a black hole.
Yeah, I don't know. It's really hard to even picture that kind of stuff, considering when we're really talking about sizes and dimensions and all that kind of stuff. It's insane as far as I'm concerned. People actually could even try to imagine some of that kind of stuff. But these are the distances that we have to cover. You have to have something kind of insane to even cover. Is there anything else that we haven't covered, though, that's a plausible science fiction thing that you've heard of?
So we didn't talk about the energy source.
Okay. We could talk about energy sources.
So one of the things that I recently found out is they've actually, I actually kind of theorized this before it came out, but they talked about a fusion reactor that all they do is they shoot in multiple pellets through a rail gun. Right. And it hits together and creates a shock wave that collides on a central fuel pellet. Mm-hmm. And that fuel pellet implodes based on the shock wave in the chamber and creates a fusion reaction that they can get energy out of. And it's all this containment concept for fusion reactors is very complicated and very dangerous.
Have you even seen the Tomahawk?
No.
So they got pictures of the ITER or whatever the current fusion reactor they got that has the current world record, and it's a fusion reaction that lasted about 36 seconds.
Yeah, they've done well.
So they are able to continuously have a fusion reaction going on using this. All right, and it basically creates a magnetic field to hold the plasma together to allow the fusion reaction to go on, but it's also going at temperatures way above what the sun does it at because the pressures are way lower. So they're talking like it's 100 million degrees in the plasma field that they're containing.
Super hot, super hot.
Yes, where like the surface of the sun's only 10 million degrees instead of like 100 million degrees. So
the trouble with any energy generating device is that it's full of energy, and that's a problem. You basically have a bomb.
Yes,
and that's one of the fusion reactors that even I'm talking about. They're exploding the fuel pellet, and it's a controlled explosion, and that's very, very dangerous. Where do you put those things? Not the center of the city. And the one that I'm talking about is very noisy. It's gonna boom, 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 boom. It's gonna shake the trees and the houses around it, and a control. That's why they need all these containment fields and a constant, steady reaction with a containment system, is so that it doesn't just explode and create all hell to break loose. And that's but this idea of this fuel pellet, if they could put it on an island far, far away, it would probably disturb marine life and things like that. And then we get the energy back in. It would. It's at least a reasonable idea. This containment system is very elaborate, and elaborate things go wrong.
Like I said, the tomahawk that they are currently generating a lot of that fusion reaction isn't too bad. They have been able to get a little bit more energy out of than what they put into it. The problem is they lose so much energy from what they're doing too, because they contain so much. Basically, it takes so much to contain it that they're burning through equipment.
They probably spent more money on the fusion reactor than they got energy out of it.
Oh yeah, by way more. This is a
fundamental problem.
$10 billion project right now.
This is a fundamental problem with humanity. We spend so much doing so much, and getting so little out of what we do, and we just create huge amounts of problems, and just this goes into this dystopian stuff. But it's just how do you the simpleness of a railgun would still even have an environmental impact because of the noise pollution, but it would be at least I want to call it simple. It's not simple, but at least it's mechanically sound and simple in design, and
it's not though. Like the Navy has tried this, and the military in the U.S. has tried for this. I mean, they have successful railguns. Problem is that the upkeep on it is too complicated.
I didn't know that.
And they don't they can't put that into service because the upkeep is just too complicated on it for the average sailor to even.
Right, I've seen that.
Think about that kind of stuff. And then you're talking about, like, it's in a saltwater environment, like how you're even going to get kind of stuff. I mean, that's why they can get the nuclear reactors on the Navy ships, because we got someplace safe to dump the explosion if it starts going crazy.
I mean, I've worked at a lot of factories, and you lose a bolt, and everybody can lose their minds. It's just one bolt.
Right.
And it just, something fell off, and now nothing works, and nobody knows what's going on. And so upkeep is just critical.
And that tends to be the biggest thing. I mean, like I said, they have them out there, but it's 6 one way, half a dozen the other. And the more complicated our weapons get, the more complicated everything gets, the harder it is for just the average person to even keep track of a lot of that kind of stuff.
Yeah, it's costly. At a minimum, it's costly. We'll just call it what it is. It costs money, it costs time, it costs energy, it costs the environment. We spend a fortune trying to make things work, and the question is how do we I mean we're getting we're trying to go to Mars, right? And
well, I think Musk will successfully get us to Mars. I mean, even that was pretty much science fiction. At least maybe not us per se, but he will get to Mars quicker with a possible human crew than even I think the governments would have been able to do it.
It's a suicide mission. It really is. It's unfortunate.
Yes and no. I mean, I think it's a one-way trip.
Yeah, I mean, I don't. Yeah, if you.
So provided that you had enough there, it's not necessarily a suicide mission. But if you don't have enough there, it can easily become a suicide mission.
So my basic concept is the fundamental limitations is the problem with a lot of this interstellar travel and the limitations of fuel. But let's say you need a screw on Mars and you don't have it. I mean, do you phone Musk up on Earth and say I need a screw, and then you spend $1 million to ship a screw to Mars?
Yeah, no, and it'll be more than $1 million probably, but. No, what you do is you put in place the 3D printer that will utilize the Martian materials to create stuff made out of Martian stuff. So you don't have to go back home. You basically place your factory there first before you send people there.
That's a chicken or the egg problem. Is do you put the robots on Mars to create the factory?
You might need to. I mean, I think that seems to be the only plausible way there. I mean, if we do send you could send a manned mission to there with a return, but I think the cost in that is just going to be super high, with not a whole lot of benefit. If you send a manned mission with a base set up, colony set up, ready to go type of thing, or to build this colony for us with an escape plan if necessary type of thing. So you just put a few humans there to begin with, enough that would fit onto the one ship that you can take out of there, and you just keep feeding them stuff until either they've gone crazy or have actually successfully started building our colony, and then you just keep sending more people there.
So the trouble I work on limitations and known facts. I mean, how long does it take to build a colony on Earth?
A long time.
And then how long will it take on Mars to build?
A longer time, because you're talking less people.
Yeah, and you're probably using robots, right, to build it.
And you're using other stuff. The nice thing is you might have prefabricated stuff being shipped from Earth to make it easier for you.
And you can only fit that in a shuttle pod, which is
and only so much space. Well, I mean, you say shuttle pod, but the Starship that Musk has built has more payload capacity than the space shuttle did.
I'm certain it does. It's still a shuttle.
It's still a shuttle. It's still a different thing. It's very
bigger,
similar.
It's bigger, but it's not that. It's not
that much bigger.
It's not that. It's not there. It's still got to take off from the Earth's gravitational field, but I mean, I would like to see it possible to go to.
So you think even interstellar travel is still kind of off? Is it just because of rockets? I mean, do we need better rockets still?
The problem is the fuel. If we could solve the energy problem, anything is possible. But energy is the limiting factor for everything. I need fuel for my body to walk around. I need fuel to build anything. I need minerals. It's the limitations that really drive everything. And with infinite energy, infinite possibilities are possible.
So, I mean, but you're just saying that we can't do it, period, then?
I'm saying there are limitations we have to overcome. And I don't know how we do that right now.
Okay.
I'm not saying it's never going to be possible, but we have a lot of things going on Earth that we have to deal with. And we're going to be.
But don't forget, I mean, Earth can just be wiped out in one shot. I mean, this is Elon Musk's other argument on it, is that as long as we're stuck on one planet, a single event for the planet can wipe us out.
We need a habitable planet, is what we need. We need a habitable planet. It needs to be terraformed. We need to find it.
You're not going to be able to terraform something else. I mean, you'd have to find a pre-habitable planet. We haven't even proven that life exists outside of the universe yet. We haven't even proven that life can exist off of this planet yet fully.
Did you hear they found organic proteins on an asteroid?
Yes.
I was like, all right, that's really good sign.
They are good signs, and there are precursor proteins that are out there in the universe.
You know what would be the optimal solution? I think the aliens have to come here, get us, we'll hitch a ride, we'll go there. They have.
Listen, I've already posted that meme on Facebook. At this point in time, if an alien come and abduct me, I'm going to consider it a rescue mission.
Thank you. It's getting me out of there.
Thanks for getting me off of this planet. I'm good now. Let's go.
Yeah. I'm okay with probing if you'll take me with you.
So, no, I get that. But, I mean, we could put more energy up to space. Why can't we just, we already launched semi-nuclear reactors up there when we launch a real one into space. Or put it onto the moon first.
I mean, are you talking the nuclear reactor that's in Oswego, or are you talking a nuclear reactor that's on a submarine? And how much energy is that, and how big does it have to be? And
more along lines that it's on a submarine type of thing, or
that's enough to
a ship.
That's enough to propel a submarine.
It is.
And is it enough to propel a spaceship?
We don't need it to propel a spaceship. We're going to use old-fashioned fossil fuels for a while.
And then use that for the rest of it?
Use that for the rest of the energy that we need.
It's not a bad idea. I mean, you can use the thrusters to keep you going once you've built up the momentum to get there. And that's probably what Musk is planning. I mean, I don't have a good idea. I haven't visited his plans yet, and that's
I haven't really visited his plans that much.
My wife is really into watching SpaceX go up and things like that. But
I've been really invested in them too since he decided he was going to do that.
And they have, the landing pad stuff that they're pulling off is really
it's phenomenal.
It's impressive stuff.
It's reduced the cost by millions of dollars to put anything into space.
I just
Starlink system
I think
or whatever.
There are a lot of hurdles to get to Mars and to set up on Mars, and it's the problem of what if I get there and I don't have what I need, and then I'm there and
you're dead now.
And we have this life supporting planet that we have everything we need to survive.
That we're killing.
I don't want to say that because it's not very optimistic, but it doesn't really send the right message. But and we have everything that we need right here that keeps us going. And granted, maybe it's not forever, but it could be for a very long time. And the future of our resources are in jeopardy, and because we're abusing them, our population is high, and that population will begin to dwindle when the resources run out, and we'll come back to equilibrium with the environment, and the human race may survive, and the Earth may go back to the way it was, and we may still have some of our technology to keep us going, and we'll be okay. I mean, we may not be at the height of civilization anymore, but we may have learned so much and be able to keep enough of the lessons we've learned to still do very well.
All right. And that leads us up to maybe another one that I forgot about. We never talked about the Dyson sphere, or basically ring planet. So
that may be something I don't know.
We build something that uses the star in our own galaxy here as our fuel source to move us through the galaxy and or other places so that we can maneuver around the universe.
So let's say we develop this technology to beam something from one point to another, the Stargate technology,
right.
And we beam small portions of the sun into our containment vessel, and we just extract that energy. That would be an interesting way, basically.
What about creating our own little star that we then use
That's what I'm saying,
as our power source?
If we can steal part of the star every once in a while and beam it over, if you could use transporter technology, all you got to do is transport a little portion of the sun into your engine and pump it out the back, and thrust occurs. You'd be at the next solar system.
Interesting. I like that thought process. That might be a new way to do it. No, but like the Dyson sphere is basically a civilization that takes basically all of our resources in our whole solar system, and we just create nothing but a sphere around our sun, and the energy that we allow to escape is actually our thrust. The whole sun.
Oh, you want to put a sphere around the sun?
The entire sun.
I can hardly get a greenhouse in my backyard. A sphere around the sun would be awesome. I think so. So solar panels it is then.
Yeah.
So one of the things that they said, one of the misleading concept about solar panels is they say that I think it's a 1% of the Sahara Desert covered in solar panels would provide all the energy humans need, but what they don't tell you is that's 54. That's I think that's 100 solar panels a household, and that means that every human on Earth would be building solar panels, and so for every human on Earth to build solar panels and then bring them up to space and put them around the sun would ultimately be a monumental task that is actually impossible because we do not have enough humans to complete the task.
Okay.
But
so generational.
Right, it would be a long-term construction project, and then by that time, solar panels last about 20 years. So by the time the generation rolls around, we would need new solar panels. Maybe they don't last 20 years. Some of my figures are a little off, but I'm estimating because of speed. Usually I research my numbers and get them right. But anybody who disagrees with my numbers, I apologize.
All right. What else we got? We've only been going for this for about 55 minutes.
Okay.
So we're almost at an hour. Why don't I just finish interviewing you for the rest of this? So what was your interest in sci-fi? How did you get into sci-fi?
Oh, I've always loved sci-fi. I think we watched sci-fi since I was a kid, and I've always loved science. I had science encyclopedias since I was a kid, and I always thought science was one of the marvels of what humanity's accomplished, and the fact that we could do magic through science was very, of course, intriguing to me.
Right. Your favorite sci-fi IP?
IP?
Yeah, well, IP is just like basically whatever program you want, whether it's anime, whether it's books, whether it's movies.
I always like Picard. Picard's the best. He always told
Star
me
Trek Next Generation.
Yeah, Next Generation. Yeah.
Have you seen the new Picard on?
I have not. And I want to see it. There's just so much media
Paramount.
out there. There's so much to watch on
much
TV.
Media out there. It's impossible to keep up with it all. I am a big Next Gen guy as well. Although I wanted to be Wesley, not necessarily Picard. I just wanted to be the smart kid that was friggin' being able to play with all the buttons and do all this. Yeah, well, definitely identified with Wesley.
I was like, we need people out there who can treat people with respect and make things happen and get everybody coordinated and on the same page. And it's a wild world out there. It's a wild world.
I think that's a big social change that we still have not mastered yet with humans. I mean, we have not gotten rid of our animal instincts, I think, enough to really do what's good for everybody.
No, it's not. It's not a realistic concept. It takes us damn near 40 years to mature, and by that time we're nearly dead. And so whether or not we get to how we get to can we accelerate that process? The internet has been tremendous in providing information to people who want it and can deal with it.
All right. But it's also tremendous time waster that has lost, I think, an average brain capacity for a lot of people because they're just not utilizing their time.
There's actually functional skills about getting out in the world and doing things for real. And you don't learn the functional skills, but you learn the book smarts from the internet and some of the street smarts by dealing with people on a level. And some people just aren't smart. I apologize. And maybe they need to.
No, I'm in a big belief of that. Like, individuals can be very smart, but I think society as a whole is not a very.
I love everybody.
Great idea. It's not a bad idea, but something better has got to come along eventually.
You mean the humans too?
I don't know about humans too, but maybe. I mean, I
always ask
my thing is
what would happen with evolution.
I always love the Next Generation Utopia, Gene Roddenberry's Utopia there, where everyone is really there trying to be the better person and not try to be like none of them were ever trying to be a bad guy generally for the most part.
Yeah, nobody wanted to be the bad guy.
Nobody wanted.
In real life, there are people out there who just I mean, let's be fair. It's not that they want to be a bad guy. It's that they've given up. They've given up, and they just don't give a shit. And that's where sci-fi, a lot of this stuff that I thought was awesome, is not representative of reality. Reality has tough things and limitations, like I was talking about. That the reality is limiting us from achieving what we need to. Well, I don't know what we need to. I've come to grips with the fact that a desire to change things and sterilize the earth of anything that isn't the way it actually is actually an act which is damaging to the environment. You want to nurture everything to be the best that it can be, because that's what people want. People want to be okay.
Right.
And I think that's what we need to do. I think we need to help everybody be okay. And okay is good enough, because when you start trying to do too much is just too much. Let's just help somebody be okay today.
All right. I think we're going to leave you guys with that as our final words here from Ryan. Thank you for watching and or listening. Please keep it up. I am sorry that this episode probably will come out before my Comic-Con one that I didn't have a chance to finish building yet. I did have some audio and video issues that I think I now got straightened out, but the biggest problem was Apple and Microsoft weren't playing well together, and it took me a good 7 or 8 hours to figure that out, on top of the fact that I still need to do a bunch of editing. So it's just not going to happen. So I'm probably going to create that one and have it come out kind of as a bonus episode in between stuff, either this week or next week. Thanks for listening, guys.
Thank you.